Our project is the Cadmium Telluride project. My name is Saad. My team members are Zaid and Salam. We are Group 33, and this is our project. What is cadmium telluride? Cadmium telluride is a crystalline stable compound that is formed from elements tellurime and cadmium, as its name illustrates. What are the uses of cadmium telluride? Well, the main use of it is as a semiconductor in the infrared optical window in both cadmium telluride form and cadmium telluride photovoltaics form. So what are the thermal properties of it? Well, specific heat at 293 Kelvin is equal to 210, and the coefficient of thermal expansion is 5.9 microns. The thermal conductivity is 6.2. As for the physical properties, Poisson's ratio is 0.41, lattice constant at 300 Kelvin is 0.648 nanometer, and Young's modulus of elasticity is 52 gigapascal. Optical applications. With the advent of the monocrystalline cadmium telluride, considerable improvements have been made on its optical properties. Currently, its crystal variants are commercially available. In addition, the compound is used as an electro-optic modulator in both the far and near infrared regions. In essence, it should contain few impurities and should exhibit a high optical performance and minimal strain so that it can be rendered effective for electro-optic modulation. Furthermore, cadmium telluride and its alloys are widely used as electroluminescent materials. Essentially, the semiconductors are fabricated with band gap specifications ranging from 1.5 to 1.6 eV in order to optimize the efficiency of solar harnessing. It has been experimentally proved that the compound has a high coefficient of optical absorption as well as a near ideal band gap. However, the use of limited recombination diodes to produce high band gaps does not necessarily translate to excellent electroluminescence. Production of thin solar cells. Cadmium telluride is widely used to produce thin film solar cells. In 2011, cadmium telluride accounted for about 9% of the solar cells that were installed globally. In fact, the cadmium telluride is one of the low-cost commercially available solar cells. However, the cost of installation is dictated by several factors, including its size, and it is subject to change over time. The market for cadmium telluride-based thin solar cells is dominated by the First Solar brand. Radiation detection. Cadmium telluride is used in gamma and X-ray detectors. The cadmium telluride can be coated with the mercury alloy to yield versatile infrared detectors. Equally, zinc alloy can be used to improve the radiation detection properties of the compound. Furthermore, the cadmium telluride used in optical windows and lenses can be exploited for optical detection of infrared. In addition, the compound can be used to detect beta and alpha radiation particles when doped with Cl2. Furthermore, cadmium telluride is stable at the room temperature and can be used to develop a compact detector for varied wavelength radiations. Nuclear spectroscopy. An extended application of cadmium telluride in radiation detection is nuclear spectroscopy. Due to its high atomic number, the material can now be used in high-performance radiation detection systems, especially those that detect X-rays and gamma rays. So, what are the challenges? One of the challenges is that the demand for cadmium telluride thin film solar PV cells has been growing at a rate that exceeds that of the conventional first solar technology and that of the SI international standard. Another difficulty is in attaining the low resistance in cadmium telluride PV cells. Another one is the complexity of cadmium telluride doping and preparation methods. The uh, key challenge to the application of cadmium telluride in poor understanding of the doping and preparation methods is because of the process is difficult to control and the thin films often yield quite erratic products. The responsibility of results makes it difficult to discriminate the minor defects from the major ones. Cadmium telluride fabricated constant points are often weak, thus the contact technology is limited to low resistivity of the P-type material to some small possible choice number. In conclusion, cadmium telluride finds wide applications in different fields, including radiation detection, nuclear spectroscopy, PV cells, laser windows, electro-optic modulation, and so forth. Ideally, the compound should be obtained in the form of thin films to give it a definite advantage in the fabrication of high-tech products. In addition, it enjoys technical advantages than its close rival semiconductor materials. Truly, the world is in dire need of reduced greenhouse gas emission. Thus, its fundamental importance in solar power harnessing cannot be overlooked. Its durability, coupled with its high performance and efficiency, promotes the use of cadmium telluride at high temperature and low cost fabrication requirements. These are our references. Thank you.